All right, hey y'all, we're looking at systems of equations, and it's a lot of fun. Maybe it's not a lot of fun. Either way, we can do it. We might as well do it. Let's go through it and see what we're working with here. So we've got ourselves a system of equations. Again, we have one or more equations, right? Okay, we got two equations in this case, and we have the same variables, right? We got y in both equations. We got x in both equations. We might not know exactly what those stand for. But eventually we'll do some problems where we do. So, okay, the substitution technique, here we go. We've got this problem ready for us, copied over here to a whiteboard, and we're going to solve this using substitution. So here we go. We've got the following thing here. We're going to start by saying y equals y, right? And we know that this is true, right? We know something always equals itself. 1 always equals 1. 100 always equals 100. X equals x, y equals y, and so on, right? So we know that's true. But here we can take advantage of the fact that y equals y, right? Because we have two y's, right? We've got a y equals 5x minus 22, and we've got a y equals 4x minus 17. So what we can really say is ultimately 5x minus 22, and let me make that look a little more like an x here, equals 4x minus 17, right? So we took our y's, and instead of using y, we substituted 5x minus 22 in for this y right here, and we substituted 4x minus 17 in for this y over here. Okay, so here we go. Now we're back to our previous semester where we worked on solving equations, and it is kind of a complicated equation to solve because we have variables on both sides of the equation. But we know what to do, right? We know that first step is to sort of move all of the variables over to one side. So step one of that would be to subtract 4x from both sides. So we're going to subtract 4x over here. And that will give us 1x. We don't need to write the 1, so we'll just write x. Of course, the minus 22 is still hanging out there. And on this one, we have 4x minus 4x. That's going to give us 0. We don't need to write the 0, so we can just write the negative 17, right? So we get x minus 22 equals negative 17. All right, now we're going to add 22 to both sides, plus 22. And we're going to note that these cancel out like this, and we're left with x equals 5. Right? So there we go, negative 17 plus 22. I could do it on my calculator if I need to, but I happen to know just from mental math that that is going to give me 5. So we've got x equals 5. All right, so we're halfway to the solution, right? We got x. Now we need to compute y. So the good news is we can use either of these equations to compute y. I'll go ahead and use the second one, and I'll switch colors for this. We'll do a purple here. So I'm going to make another substitution now into this equation. I have y equals 5x minus 22. And I'm going to substitute this time. I'm going to substitute in x equals 5. So that means y equals 5 times 5, right? Because we take it from right over here. We know x equals 5 minus 22. So that means y equals 25 minus 22, or y equals 3. Okay, perfect. So let's come over here, put in our solution. We can double check it if we want to. We could maybe check by graphing or something. Y equals 3, and x equals... what did we say x equaled? X equals 5, right, and y equals 3. Okay, and we'll type in solution. Okay, there we go. Solution, x equals 5, y equals 3. Looks good. Okay, there's one done there. Let's come on down to slide number 6 and look at a different scenario. Okay, here we go. Here we've got 2x plus 2y equals negative 2, and 3x plus 2y equals 12. This is slide 6. So here we go, and now I happen to have created a slide for this earlier. Here it is, 2x plus 2y equals negative 2. Here's 3x minus 2y equals 12. Okay, so this is a little bit trickier because we can't just straight up start with that y equals y, right? We're going to have to manipulate some things around before we do that. So one option we can do is we can just start with this equation here. Maybe let me just copy this one and paste it. And we can just solve for y in this equation, right? So step 1, let's go back to our black pencil here, would be let's subtract 2x from both sides. Minus 2x minus 2x. And then we're going to end up with this. We're going to end up with, that's going to cancel out and become 0. We're going to say 2y equals negative 2x minus 2. Okay. Now I want to just know what y is. I want y by itself. So I'm going to divide both sides here by 2. So that means I got to divide both sides by 2, right? So I need to divide both the negative 2x and the number 2. I need to divide everything on this right-hand side by 2. Okay, so that's good. That's going to cancel out. I'm going to end up with y equals negative x minus 2. Okay, so I haven't solved anything. I don't know yet what y equals, but I do know that y equals negative x minus 2. Now, I see we're getting a little bit low on space, so I hope you guys will be okay if I do this. Y equals negative x minus 2, right? So we computed that by adjusting, by moving 2x to the right-hand side, dividing both sides by 2. And here we go. We're off and running. Let's go ahead and delete this. And we'll move this up here, right? So here, these two things are equivalent, right? This is the same equation. It's just written in a different form. It's written with y by itself. So what I'm going to do now is I'm going to take this one, 3x minus 2, and instead of writing y, I'm going to write this, negative x minus 2. Okay, and that of course equals 12, right? So I'm again using the substitution method. In this case, I'm substituting y for negative x minus 2. So here we go. First thing we need to do here is a distribution, right? We need to use that distributive property and multiply negative 2 times negative x minus 2. So that's going to be 3x, that one's unaffected thus far, plus 2x, right? Because we're multiplying a negative 2 times a negative x, result's going to be a positive 2x, and then negative 2 times negative 2, that's going to give us a positive 4. And of course, this is equaling 12. Okay, there we go. So we're going to end up with 5x 5x plus 4. So I'm just combining my 3x and my 2x. Total x's equals 5. And yes, have I made any mistakes? No, I don't think I have. Equals 12. Okay. Now we're going to subtract minus 4 from both sides, minus 4. So that it gives us 5x equals 8. And then x equals 8 over 5. Okay, so we have a fractional answer here. Not so easy to work with, but in real life, numbers get messy. We know this. Okay, let's switch up our colors now. Go to this nice rust color. Okay, so we're going to do our last substitution here, and I'm going to actually use this one. We know y equals negative x minus 2. So I'm going to say y equals negative 8/5 minus 2. So let's see. Actually, maybe we can use the calculator for this one to make it easier. We'll say negative 8/5 minus 2. Maybe we'll wrap parentheses around our fraction just to be real sure that we got it. And that is going to be negative 3.6. Okay, negative 3.6. All right, so we can go ahead and write in our solution just so we know that this one, x also equals 1.6 if we were to write that out as a decimal. So, okay, we'll do decimals. Equals 1.6 and negative 3.6. Let's put our answer in. Maybe here. Okay. Solution x equals 1.6. Y equals negative 3.6. And there we go. Two different substitution problem examples for you right there. Good luck. Have fun. Work hard. You can all do this. I believe in you. And I'll see you soon.